our video presentation for MAT263 Linear Algebra. We are excited to share our group project with you. But before we begin, let me introduce our team members. First, we have Muhammad Faris Najmi bin Muhammad Yassin. Next, we have Sharifah Nazrata Aliana binti Zaid Zahari. Moving on, we have Adam Haziq bin Muhammad Fadil. And lastly, we have Nik Muhammad Anas bin Maksum. Now, let's begin our presentation. The title of case study is Finding the Production Quantity of Pastry at Amir Pastry using ghost theory method. In this project, we apply the ghost theory method in linear algebra to determine the suitable production quantity for each type of pastry produced by Amir Pastry. Next, I will present the introduction of our case study. Amir owns a pastry shop and plans to bake 4 different types of popular pastry, which are cupcakes, croissant, butter cake, and churros. Each pastry requires different amounts of ingredients, including butter, egg, milk, and flour, based on their respective recipes.
Next is problem statement. Our problem statement is to determine the number of units for each type of pastry that can be produced while maintaining a constant production ratio. Given the available ingredients of 1.2 kg of butter, 27 eggs, 1.3 liter of milk, and 2.05 of flour. This study aims to identify the optimal combination of pastry production that fully utilize the available ingredients without any waste while maintaining a balanced manufacturing process. For our purpose of study, first to model a multivariable commercial baking recipe system using linear equations. Next, to apply Gauss-Jordan elimination on a 4x4 augmented matrix to find the precise production quantities. The last one is to determine an efficient production combination based on the available ingredients while minimizing ingredient wastage.
Next, we apply the concept of linear algebra by representing the given information in the form of a 4x4 augmented matrix. Then, the Gauss theorem method is used to transform the matrix into reduced row echelon form in order to obtain the value of A, B, C, and D, which represent the production quantity of each pastry. Now, I will pass the presentation to my next group member to continue the calculation and solution process.
First, we define our variables. We let cupcakes be A, croissant be B, butter cake be C, and churros be D. Next, we construct a system of linear equations based on the problem statement. As you can see on the slide, we form 4 linear equations. And then we convert this equation into a augmented matrix, which sets us up to solve the system easily. First operation, we start by swapping row 1 and row 2. This places a smaller leading coefficient at the very top to make our calculation much cleaner. Second set of operations, next we want to create zeros below our leading coefficient in the first column. To do this, we perform 3 operations simultaneously. We update row 2 by subtracting 25 times row 1. We update row 3 by subtracting 50 times row 1. And we update row 4 by subtracting 75 times row 1. Third operation, moving to the bottom row, we need a leading one in row 2. We achieve this by multiplying the entire row 2 by 1 over 75. Fourth operation, now we need to eliminate the entry below our new leading one in the second column. We update row 4 by subtracting 135 times row 2. Fifth operation, finally, we want to get a leading one in row 3. We scale row 3 by multiplying it by -1 over 100.
On this slide, we continue solving the system using Gauss-Jordan elimination. We start with row 4 reduced to 0, 0, 0, negative 150, and negative 750, and scale it by negative 1 over 150 to get a clean pivot of 1. Using this pivot, we eliminate column 4 from the other row with R1 minus 2R4 and R3 plus 1 over 2R4, giving us the matrix on the top right. Next, we shift focus to column 3, applying R2 minus R3 and R1 minus 3R3 to clear it out. Then we scale row 1 with R1 over 2 to get the pivot of 1, and finish with R1 minus 1 over 2 up 2 to clear the last entry to reaching the full identity matrix. From our final identity matrix, we successfully extracted the exact quantities. Cupcake equal to 2, crescent equal to 4, butter equal to 3, churros equal to 5.
Now, for the discussion part, based on our calculation, we found the optimal production mix ratio for Amir's bakery, which is exactly 2:4:5. By using this exact configuration, the bakery achieves full manufacturing balance. This means we perfectly utilize all the ingredients: 1,200 grams of butter, 27 eggs, 1,300 ml of milk, and 2,050 grams of flour. As a result, no single ingredient is wasted or left over, making the production 100% efficient.
For conclusion, this study successfully demonstrates that a 4x4 multi-variable inventory management problem can be solved linearly by transforming a kitchen recipe into an augmented matrix and processing it via Gauss-Jordan elimination. Complex production balance become clear. This mathematical tracking allows food business to operate with absolute certainty, maximize inventory turnover, and systematically eliminate supply waste.